So the system that we're modeling is a hot dog store, and it has only one server, so it's a single server queuing system. So customers arrive at the store, they walk to the queue, they wait in the queue if there is any line, and then whenever the server becomes available, customers place their order, they wait until their hot dog is ready, they get their food, and they leave the system. So we're given some data about the operation of this system. As you can see here, the arrival rate is 20 customers per hour. Service times are triangularly distributed with a minimum of 1 minute, a maximum of 4 minutes, and a most likely value of 2.5 minutes. The queue rule is first in, first out, and customers' walking speed is 1 meter per second, and our system operates from 10 a.m. to 10 p.m., basically 12 hours per day. And the performance measures that we're interested in are server utilization, average and maximum expected number in system, and average and maximum expected time in system for our customers. So for this model and most of the basic simulation models, we can simply use the objects in the standard library. So these objects are general objects that are applicable to most simulation models. So for this model, we need a source object to generate our entities, and a server object, which is basically our hot dog preparation step. And finally, we need a sync object to destroy the entities that leave the system. The next thing that we need to do in our model is to connect these up. So for that, we have multiple options here in Simio. Connectors are different from path objects in the sense that the transfer time when you use a connector is basically 0. So entities are transferred from the starting point to the end point of a connector in 0 simulation time. So let me actually go ahead and show you what that means. So I'm going to add a connector between my source object and my server object instance, and also I'm going to connect the output node of my server to the input node of my sync. Now I can go ahead and run my model and watch the model run. And as you can see, we are not able to see the movement of entities along the two connectors. So it seems that entities appear at the server object instantaneously, and then we cannot see when the entities leave the system through the sync object. So let me stop the model and show you exactly what's happening here. So if I run the model in the step mode, you can see that my first entity is created at exactly 0.00 hours. And I'm going to hit step again to move ahead to the next event, which is the arrival at the server object. And in fact, when you look at the simulation time, we're still at 0.00 hours, which is exactly what we expected. Like I said, when you use connector object instances, the transfer time is 0, so entities are transferred in 0 simulation time to the end of the link. But of course, this is not what we want in this model, so let me go ahead and delete these connectors. Of course, in this model, since we have distances between different components of the system, and also we have the walking speed of customers, and also because I want you to be able to see the flow of entities in the model, I'm going to use a path object. So I'm going to click on the path object and then connect the output node of my source object to the input node of my server object. And I'm going to do the same thing to connect my output node of the server object to the input node of my sync object. Now, one last thing that I want to add to, or one last object that I want to add to my model is the model entity. So I'm going to add an instance of the model entity definition to my model, and I'm going to rename it and call it customer. So now I can click run, and as you can see, the model is running, so entities arrive, they wait in the queue if there is any line, and then they get processed and leave the system. And you can also click on individual objects in the model and see its different properties on the right hand side. So for example, when I click on the source object, I can see that this source object creates entities of type customers, and then the arrival mode is inter-arrival time, and the inter-arrival time is random and exponentially distributed with mean 0.25 minutes. So those are the default properties of the source object. You can also look at the properties of the server object. Let me expand this a little bit. And as you can see, for the server object, the capacity is 1 and the processing time is triangularly distributed with 0.1, 0.2, and 0.3 minutes. So, so now that we know that everything is connected in our model, we can go ahead and input our parameters. So for our model, we know that the arrival rate is 20 customers per hour, and it follows a Poisson distribution. So that tells us that our inter-arrival times are exponentially distributed with mean 3 minutes. So what I'm going to have is to change my inter-arrival time to exponential with mean 3 minutes. I also need to specify my service time here, which is triangularly distributed with parameters that are given here. So I can click on the server object and simply modify the values here, but I would like to show one other feature of Simio here, which is the expression builder. So the expression builder helps you to type expressions. So let's say I would like to specify the service time of my server. So what I can do, I can simply type random, and as you can see, the expression builder helps me identify related words here. So you can either double click on random, and when you click type dot here, you will see the different options that you have from the random library. So the different distributions that you can use here. So for this model, we know that the processing times are triangularly distributed. So I can basically go ahead and either double click on triangular or simply type it here. So triangular with parameters 1, 2, and 2.5, and 4. And I selected the expression by mistake. So 1, 2.5, and 4. So as you work with Simio in the future, you will find the expression builder very helpful, especially when you don't know the exact expression that you need to type in. So now that we have our inter-arrival time and service times specified, the other thing that we need to specify is basically deals with the physical layout of the system. So we know that the distance between the entrance to the counter is 8 meters, and the distance between the counter to the exit is 5 meters, and we would like to incorporate that in a model. So for our path objects, we have basically two options to specify the length. So we can either when you click on the path objects and look at the properties, you will see that you can either draw to scale, or if you set this value to false, you can basically specify the logical length here. So I'm going to use both approaches here. So for my first path that connects my source to my server, I'm going to draw it to scale. So basically Simio will consider the physical distance between the two nodes here. So when you go to your units, you will see that the unit for length is meters. So each of these squares between the that you see here is basically representative of 1 meter. So I need 8 of these between my source and server. So let's see, 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. So since I've selected the true value for a drawn to scale property, Simio will now know that the distance between my source and my server object is 8 meters. For the second path here, I'm going to use the other option. So I'm going to set the drawn to scale value or property to false, and instead set its logical length to 5 meters. One last thing that I need to add to my model is basically this walking speed of my customers. So I'm going to click on customer and basically go to its properties, and as you can see, the first property of my model entity here is its desired speed. So what I'm going to do, I'm going to change the default value from 2 to 1, and just need to make sure that the units are consistent. So meters per second, that's what I want. So now I have basically completed my initial model, and I can run it in the interactive mode and watch the model run and basically see how our entities flow and get processed in my system. So now that we have our initial model, we can go ahead and do some experimentation with it. So the first thing that I'm going to do before running my experiment is to set the run configurations. So I'm going to start my model at 10 a.m. and I'm going to set the run length to 12 hours, since we know that our system operates from 10 a.m. to 10 p.m. So now when I run my model, it starts at 10 a.m. and if I click on fast forward, you will see that it stops at 10 p.m. exactly at after 12 hours. Now I can go to the results tab and see the results of my interactive run. So you can see the Simio pivot grid here that provides your simulation outputs that are categorized by different objects and items. So for example, you can click on model entity and you will see that we have only one type of model entity in our model, which are our customers. And you can see that we have the number in system and the time in system, and for the number in system we can see the average and maximum, and for the time in system we can see the average, maximum, and minimum. And of course for the number in system, since we start with an empty system, the minimum is 0. We can also look at our server objects, and we have only one server object, which is server 1. And if we look at the capacity category, and under the data item scheduled utilization, we will see this utilization of our server. And we can also see different statistics that are related to the input buffer, output buffer, processing station of our server, and also the statistics that are related to our sink and to our source objects, such as the number that were created or the number that were destroyed by our sink object. Now, an important thing here is that if I reset this model and go back to my facility view and run my model again, I'm going to see the exact same values here for my simulation outputs. And the reason is when you run your model in the interactive mode multiple times, you're not basically replicating the model. You're just repeating the exact same scenario, and it's because Simio uses the exact same stream of random numbers to generate your, in this case, inter-arrival times and service times. So we know that since we are dealing with random numbers here, one run of the model is not enough to make any decisions. So what we need to do is to replicate our model, and in order to do that in Simio, we need to go to the Project Home ribbon and create a new experiment. Now you can see the design of or properties of your experiment here. You can simply set the replication number here, and I'm gonna set it to 200 as specified, and I'm gonna hit run, and the run is over. So I can now go back to my pivot grid and look at my simulation outputs. One thing that you note here is that I have 3 more columns here, which gives me the minimum and maximum values across my replications. And also, you can see the half-width of the confidence interval over your statistics on the 3rd column, which gives you some information about how accurate your estimations are. So another nice feature of the Simio pivot grid is that you can filter out some of the statistics and narrow down your pivot grid to the statistics that matter to you. So what I'm going to do, I'm going to just focus on the model entity and server objects, and then just the population and resources, and resource, sorry. And I don't care about holding time, resource state throughput. And what I want here is number in system, time in system, and scheduled utilization. And since I'm only interested in the average and maximum time in system, I can look at average, maximum, average hours, maximum hours, and percentages here. So now I have narrowed down my pivot grid to the 5 performance measures that I care about. So in this video, we built a simple single server model in Simio, and specifically we talked about some of the basic Simio objects, such as the source object that is used to create entities, and the server object that is used to model a processing station. And we also talked about the difference between connectors and paths. We showed 2 different ways of implementing the length of the path objects in our simulation models, either by drawing to scale or by setting the logical length for our path objects. We also talked about basic ways to input the parameters of our model, either by directly typing in the corresponding field or by using the Simio expression builder. We also talked about different components of, let me close this, different components of the Simio pivot grid and how we can read the results from our Simio pivot grid and its different components. And we also showed how to create an experiment, change the number of replications, and also we discussed how we can filter the results in our pivot grid. One last thing that I would like to mention is that in another video module we will use queuing theory to perform a basic verification of the exact same model of our hot dog stand system.